So, first of all, I have to tell you I'm a little daunted to come and speak at this conference. The best way I can describe this to you is that I feel like a guy who designs and builds roads and freeways coming to tell Enzo Ferrari how he should design a race car. So I'm sort of out of my element in a way, because I'm the guy that likes to work on the underlying plumbing of the system that you build all these cool applications for. So if you were expecting me to come and tell you all about Google's applications and the ones we haven't announced and everything else, I'm sorry to disappoint you, but I'm not going to do that. I'm actually going to talk about the problems below the level that many of you are dealing with and where I think we need to go in order to allow you to keep doing what you've been doing. Now, before I do anything else, I just noticed that there's no power on this laptop. That's because there was this little swap of machines earlier. Okay. So here we go. This is what the internet looks like. This says 1999. If it was 2010, it would look about the same. This is a picture of the connectivity of the net. The different colors are different autonomous systems. And what you're seeing here is an interesting sociological fact. The network isn't run by any one entity. It is a collaborative activity. People voluntarily decide to build pieces of internet, connect them together, and make the service on top of which the World Wide Web operates. I still think it's pretty amazing to see that this system can be run in such a distributed way. So the 2010 version of this is just bigger and more colorful and more connected. The number of machines on the net continues to climb. The ones that are visible are reaching on the order of 750 million machines, but that does not account for all the machines that are actually not visible on the net. Probably at least that many of them are hiding behind firewalls. Certainly many of ours at Google are not part of the publicly visible components of the net. These are the ones that have domain names and have typically fixed IP addresses, so there's lots more than that on the system. The number of users has reached an estimated 1.8 billion. That's continuing to grow, not surprisingly. That's only about 26% of the world's population. So it's the chief internet evangelist at Google feels like he's got about 75% of the world still to convert. So I have a long life and effort ahead of me. The other thing that's interesting is the somewhere between 4.2 and 4.5 billion mobiles that are in use today. About 15 to 20% of them are internet enabled. That's an important statistic for two reasons. First of all, it's the most rapidly penetrant telecommunications technology in history. And it also represents a growing access method for the web-based products and services that we all know and love. It's a big challenge to offer some of these web-based applications in a constrained space and a constrained data rate, or highly variable data rate. So this is something which we all need to take into account, because for many, many people in the world, the mobile will be the first and sometimes maybe the only avenue for getting access to web-based applications. Here's where the users are. I continue to be quite impressed with the rapid growth of our Asian colleagues on the network. About half of the Asian population is in China, in mainland China. And that only represents, as you can see, about 20% penetration. So without any question, as the internet continues to penetrate, a greater degree of users on the net will be from that part of the world, with their languages and interests and styles and cultures bringing it along with them. The others are, as you see, I've given up all pretense of predicting anything about Europe, because they keep adding countries, so you don't know what the definition of Europe is. But at this point, anyway, it's over 400 million users at over 53% average penetration. And of course, you all know that as you go north into the Scandinavian countries, there's a higher and higher percentage of penetration, up in the 75 to 80% range. We've all wondered exactly why is it that the Scandinavians spend so much time on the net. At least one notice is that the winters last a long time up there, and there's nothing else to do except surf the web and talk to your friends on your mobiles. So the rest of the world is, as you see it, still only 26% penetrated. The number of IP addresses that are available under the IPv4 design is dropping rapidly. I mean, we're using them up, basically. The current estimate is that we will have exhausted IPv4 address space sometime in the middle of next year from the standpoint of the Internet Assigned Numbers Authority at ICANN, and then the regional Internet registries will have exhausted their allocations most likely sometime in 2012, which suggests that the Mayans must have known something that we didn't know. The implication of this, obviously, is that we need to introduce IP version 6. So those of you who are paying attention at all will know that I'm spending a lot of time, as are my colleagues, trying to persuade people to implement v6 in parallel with v4. The number of addresses in v6 is computable. It's 2 to the 128, 3.4 times 10 to the 38th addresses, which is a number only the U.S. Congress can appreciate, I think. I used to go around saying that this meant that every electron in the universe could have its own web page until somebody pointed out to me, you know, dear Dr. Cerf, you jerk, there's 10 to the 88th electrons in the universe and you're off by 50 orders of magnitude, so I don't say that anymore. Yeah, if I make a mistake, I might as well make a big one. Internationalized domain names are not new. They've been around to first order since 2003 when the first IDNA, Internationalized Domain Names for Application standards, were developed. Recently, the IDNA 2008 standard was finally released to the RFC editor after 2 years of fairly tough work. It's an important piece of work, though, because it more accurately defines what is and isn't a valid internationalized domain name. Now I need to draw your attention to the fact that you need to be paying attention to implementing this new design in your browsers and other applications that deal with URLs, URIs, and the like. Domain name system security is a very, very important part of the Internet's infrastructure, and we're seeing DNSSEC showing up. The root zone should be signed sometime in the middle of the year, or at least during the summer. Other top-level domains are already signing their zone files like .bg, .se, and others. We also have some problems in the routing part of the architecture. The issue here is that the network was developed in a time and with a group of people who mostly trusted each other. And so a lot of assumptions were made that people wouldn't cheat, wouldn't lie, wouldn't try to attack the net because we were just trying to get it to work. Well, now that it's all out there and it's been there for quite some time, it's spreading rapidly into the general population, and we're seeing abusive behaviors. In the case of routing, it's possible to lie, to say, hi, I'm connected to this, please send me everything that's going there to me, and either black hole the traffic or actually capture the traffic and do some bad thing with it. So the routing tables now need to be updated only if the parties who are advertising that they're connected to that part of the address space actually can show authority that they've been allocated that address space. And that's why the regional internet registries are proposing to digitally sign every allocation of an IP address part of a table. You can look it up when you're doing the routing updates. There are sensor networks that are coming into the Internet's ambit, and I'll give you an example of that in a little while. The smart grid in the US and similar programs outside the United States are going to bring lots of appliances into the Internet's environment as well. There are a couple of motivations for that. One of them is that if you had a better sense for how you were consuming electrical power, you might do a better job of it. And second, the power generation industry would like very much to be able to moderate demand for electrical power, especially when you're reaching peak loads. So things like air conditioners or water heaters and other things that could be turned off or could delay their demand for electricity could actually help get through a demand without having to build a lot of very expensive power generation equipment that only gets used 2% of the time. Mobiles, we've already mentioned. Cloud computing and social networking are new parts of the Internet's environment, which are also becoming quite important. So there are some implications of the state of the Internet today for what you are doing, and I want to suggest a few. On the mobility side, one of the big problems with mobiles is that they aren't really always connected. We try. but in fact they get disrupted. The consequence of that is that you can't rely on being able to maintain a persistent connection continuously. So you have to design systems that are essentially transaction-like, that are expecting to be disconnected at any moment, and then you have to somehow find a way to reconnect and reestablish the state that you were in at the time. Fortunately, the HTTP environment has a very nice match with the idea of almost stateless behavior. Using cookies and things like that to establish a state is very helpful in that regard, because the state information is held on the remote device, and when you reconnect, that data is available to the servers. We also are seeing very wide ranges of access bandwidths on the network. And so one of the things that is very attractive, especially in the mobile environment, is to consider having more than one way of having a mobile connected to the network. So you might have, you know, WiMAX or 3G or 4G or LTE, but also Wi-Fi and multiple radios or software-defined radios may become a part of the normal mobile environment, allowing us a much more flexible way of staying connected to the net as we move from one radio regime to another. I'm also seeing that mobiles are beginning to be capable of engaging in interactions in sensory environments that they didn't have before. So mobiles have cameras. They can capture video. They can capture still images. They can capture continuous video images. They can pick up sound, they can pick up speech, they can offer multi-touch kinds of displays, or they can actually be used as sensors. And there are some applications now where the mobiles have been outfitted with sensors to detect hazardous substances, chemical or biological or even radiological. The notion here is that everyone can become a reporter of information in addition to becoming a consumer of information, and the mobile devices are one of the avenues through which this is happening. So we are becoming a community of information producers as well as information consumers, in part because of the flexibility of the mobile devices that we carry. Certainly, all of us who are interested in search are interested in getting beyond the simple text search that has been so powerful up until now. So Google is quite interested in being able to, as are others, in comparing images and trying to find similarity between images. Google Goggles, if you've seen some of our videos, allows you to take an image, maybe with your mobile or something else, and then search our databases for similar kinds of images. For example, if you take a picture of a book, if we have that book in the database, we'll search for the book cover, and then we'll be able to tell you who wrote the book and where is it available and how much does it cost and what are its, what's the subject matter. Or maybe it's an image of a famous landmark like the Taj Mahal or the Eiffel Tower. You can take a picture of that and search the database and get more information about it. Or maybe even a barcode, which can be recognized in a database fairly simply. We work very hard at Google on speech recognition. We've tested this in many different ways, but people who are using hands-free mobiles often find it easier to surf the net orally rather than trying to type things in by texting and keyboards. Patty Mays showed an absolutely wonderful example of gestures, and I have some of you have probably seen this video from TED. Later on, I'll pull it up just for a few minutes to see what was happening there. But the idea is that instead of carrying a textbook style laptop or something, you just have a video receiver, a camera, and a projector. The camera can see what you're doing. It can see gestures, and it can respond to them. It actually puts the computer into the same environment that you and I normally interact with, putting the computer into a position to use the same kind of inputs that we use in order to work with the real world. And finally, there's this deep linking and semantic web effort which continues to make progress. I think of a lot of the information in the net as dark information in the same way that there's dark energy and dark matter in the universe. Only 5% of the matter in the universe is us, and this, the visible matter in the universe. The rest of it is all dark, and we don't understand what it is. In the web, there is a lot of structured information which is not visible to the search engines because it doesn't manifest in the form of HTML or XML. And you certainly don't want to send a crawler to go squat on a database and ask a million questions in order to figure out what's in it so that you could get the HTML out to index it. So we clearly need to do some serious work to help discover and articulate the information that's out there in this structured form. Last night, I was having a brief conversation at a reception with Thomas Rösler, and I misunderstood him. He said something about web applications, and I thought he said web publication, and I sort of stopped dead in my tracks thinking the term web publication might have a deeper meaning than simply putting text and imagery and video and sound on the net. Imagine for a moment that by publish, you typically mean I want information to be made available to someone who can use it. And although historically that's been in the form of papers like the ones that you wrote for this conference, making information available in the form of databases and making it available in the form of something that's computable and manipulable is a very important kind of publication. And I'd like to suggest that it's very attractive to imbue this term web publication with the idea that when you publish data in some structured form, it's in a form which can be used by others. It can be fused with other data that's available. And thinking through how to make that actually useful, I think, is a very big challenge. And then this notion of semantic printing. I mean, we print on printers and make paper that you can read. We sort of print on the web to make text and imagery that you can read. But the idea of printing something that has semantic meaning that can be processed by a computer is part of what I think, anyway, the deep linking and semantic web ideas are all about. All of these, I think, are still very nascent in terms of availability. Identifiers have also become a very interesting issue. We use domain names now regularly. They appear in URLs, URIs, and URNs, and so on. But they have the unfortunate character that a domain name is not permanent. It can disappear, it can be reassigned. There are all kinds of reasons why identifiers that are locked to domain names are not stable. Now, we do have URNs, we have URIs that are intended to be more persistent. But this raises another very interesting question. What do these identifiers identify? And in general, in the past anyway, URLs have, and specifically domain names have tended to identify a computer somewhere. There are other more general notions that allow you to identify an object. The question is, what's an object? Is it a document? Is it a file? Is it an executable program? Is it a running process that's somewhere? So figuring out what we want objects to be is part of the interesting design challenge. How do I find the objects? What mechanisms do I use in order to discover them? Is it a directory system? Is it an indexing system? Is it a broadcast system that says, hi, where are you? I'm looking for this. Are all objects unique? Can I say, find me any instance of that object? Is there a way to express that? How do I interpret the object when I finally find out where it is? Do I need a computer to interpret it? Do I need a program to interpret it? How do I interact with it? Does it have a vocabulary? Does it have a command set? How do I know that it's still okay? How do I know that the object is as it was when it was put into the system to begin with? And how do I know where it came from? Some of these questions are really important because the objects that we often deal with are code that we download and run. And it's increasingly important for us to know where did it come from and has it been altered since it was originally made available. And until we solve those problems, we are at considerable risk. So authenticity has now become an increasingly important element in the vocabulary of the web and the internet. So we have these notions of digital signatures thanks to public key cryptography, but the question is, what value should we assign to them? To give you a trivial example, suppose that we engage in a dialogue on the net and we come to a conclusion about a contract. And we each digitally sign this contract using some public key capability. The question is, how will that contract be treated in the courts? You know, suppose that one of us fails to meet the commitments that are in the contract, and the other guy says, this isn't right, I'm suing you for breach of contract. In which jurisdictions will a digital signature be honored? And the answer is, I don't know, and I suspect a lot of us don't know. And the consequence of that is that we have to imbue the legal system, not just domestically, but internationally, with notions that give weight and value to digital signatures. But that now asks under what conditions were the signatures or the certificates that support them issued, who had the authority to issue a certificate, and what does it mean, how carefully was it validated. Generally speaking, authenticity of everything, including the physical components of the internet. Am I really talking to the router I think I'm talking to? Am I really talking to the server I think I'm talking to? There are a lot of things in the net today which are essentially unauthenticated, and we simply trust them. I think over time we're going to have to build a better structure of trust into the system. To give you an example of a way to build this up, imagine for a minute that somebody named Joe says, hi, I'm Joe, and he sends me a message saying, this is my public key. Now, all I know is that there's somebody named Joe, and I got his public key. So what's my first step in trying to authenticate? Well, I might send a random number back to Joe, encrypted in his public key, saying, well, Joe, if you have the matching private key, you'll be able to decrypt this packet with my random number in it. Please send it back to me using my public key, and here it is. So if Joe does that, I now know that Joe has a public and private key that work, and he has my public key, and we are now able to communicate with each other and to first order, able to sign and to protect and make confidential our exchanges. But that's all we know. So, you know, someday, you know, we're having these exchanges, and I'm keeping track of what I'm doing with Joe. And then one day Joe says, I'd like to borrow $50,000. So my first reaction is, well, Joe, I know that you're Joe and you have this public and private key, but I need to know a little bit more about you before I loan you $50,000. Do you have a job? Do you have any collateral? Where can I reach you in the real world as opposed to over the net? So I have a bunch of questions, and Joe sends answers back. The problem is I'm not sure that I can trust Joe's answers, so now I end up having to go to a third party saying, here's this guy Joe, here's what he claims, can you validate that for me? Well, what you can see in this scenario is kind of an escalating collection of trust built up based on increasing amounts of information that I've asked Joe for, but it started out with a very simple notion that Joe had a public and private key and a label called Joe, and that's all I knew. And I like the idea of being able to start with nothing and build up only to the degree necessary the details that I might need in order to interact with Joe in some context. Well, there are lots of security problems on the net. You can see this long list of them here, and I won't go through every one of them. The thing that I want to emphasize is that this is not just technical. There are a lot of problems here that are a consequence of bad user behavior. It's a consequence of people succumbing to social engineering. You know, classic example is that somebody calls the operations center on the phone, clearly very excited. The world is coming to an end. The routers and the servers are crashing, and I've forgotten the password, and you need to help me. The company will go out of business, blah, blah, blah. And maybe you mention the name or two of somebody that this person in the ops center might recognize. And in the frenzy of, holy cow, the world is falling apart, a piece of information gets divulged that lets this party actually get in when he or she has no authority to do that. So this kind of social engineering is a very popular tactic in the world of security breaches. We're all guilty of picking really lousy passwords, and we're guilty of using them for everything because it's the only way we can remember them. And we should be ashamed of ourselves. And I particularly don't like systems that have reusable passwords, because if they ever get exposed, it means that everything is exposed, that password unlocked. So a better idea is to have passwords that are one-time use. One way of doing that is using random number generation and two-factor authentication with devices that can actually produce these random numbers with sufficient randomness that even if somebody can see you use a particular non-reusable password, it doesn't help because they can't use it again, even in a replay attack. So phishing and pharming, these are compromises of the domain name system, and once again, building up better domain name system implementations and using DNSSEC, among other things, are absolutely necessary. But I think the worst problem that we have, to be quite honest, is that we make spectacular mistakes as people. Some of the worst things that have ever happened on the net that I can remember personally have been the result of somebody just doing something not quite right. So we had one embarrassing incident at Google. You know how we crawl the net and we look for malware. And we aren't certain, but you know, our software tries to figure out a website that might be infected, and then we flag that site as having potentially dangerous malware on it. And when you go there through the Google search engine, we pop up an interstitial page saying, you might not want to go here because we think there's malware and it might harm your machine. Of course, we give people the opportunity to go there anyway, but we make them do a cut and paste instead of just clicking OK. And of course, lots of people do that, and we can't help if they ended up in trouble. The problem, the mistake that we made, is that one of our ops guys who was in the process of shipping out the most recent update of that table was doing some editing to it, and he put a slash in someplace that didn't belong, and it marked every website on the internet as having malware. So for about 40 minutes, no matter where you went in the Google search engine, this interstitial page popped up saying, hi, don't go there, there's malware. Of course, this was called to our attention fairly quickly, and we fixed it. But it's an example of the kind of dramatic things that can go wrong when you're dealing with configuration. So if anybody is looking for a dissertation topic, the problem of detecting a bad configuration is extremely hard. And if you can think of good ways to solve that, it'd be very cool. So why do we have so many security problems in the net? Well, one of them is that we have operating systems that allow themselves to be invaded. Probably more important, especially to this audience, is that we have naive browsers. By this I mean browsers that will sort of download anything and then try to interpret it without being suspicious of it. Or they operate with so much privilege in the operating system context that if there is a piece of malware, the malware is able to go and touch parts of the operating system that it shouldn't get access to. Our attempt to contribute to improving matters with the Chrome browser is an example of that, where we're trying very hard to isolate processes from each other and from the rest of the operating system. We don't necessarily have good access control practices, improper configuration I just mentioned. The thing is that we all worry about the botnets because they're the origins of spam. They are the ways in which denial of service attacks are launched, but that's the symptom. The cause of the problem is that we have compromised computers because browsers are the primary mode now, the primary vector for infecting machines and turning them into parts of the botnet armies. You can understand that the botnet herders are not interested in destroying the internet. Botnets are a way of making money, and so they're very interested in keeping them running. They're very interested in making them essentially invisible to you. They don't want you to notice that your machine is infected. It's important to them that you not notice that. So it's sort of like parking your car in the driveway and leaving the keys in the car, and people making use of it while you're asleep. The worst part about this is that it's gone from a sort of a cottage hacking behavior to organized crime and sometimes state-sponsored cyber warfare. And that's a serious issue, especially in places like the United States and elsewhere, where we are increasingly dependent on the internet, either its technology or the public network, as part of our day-to-day business operations, or part of our day-to-day personal work. I would like to make an advertisement for an organization called Stop Badware. It is now has been extracted from the Harvard Berkman Institute as an independent, not-for-profit company. Its job is to help identify websites that have become infected. Google and others are participating in Stop Badware. We send them the lists of the websites that we think have infected software. And if somebody complains, like someone says, my website isn't infected, you're wrong, the Stop Badware guys will go and do a thorough analysis and come back and say, well, either, yeah, you're right, it's not infected, or you're wrong, it is. And if they say, but I didn't put it there, the answer is, yeah, you didn't put it there, but your host was weak and it was penetrated and somebody did put malware on the site. So the Stop Badware group is trying to at least help filter out and improve the situation. So if those of you who are interested in that, please go to stopbadware.org and see what you can do to participate. Privacy is another big issue in the web environment, and some of it has to do with just the way we behave. We put up information that other people would consider inappropriate or unsafe, and we do it either out of ignorance, we do it out of egotistical pleasure for displaying whatever it is that we're doing, but it does have consequences, and I think we are seeing some of those now. But we also have problems that a lot more personal information is accumulated, even in many cases perfectly legitimately. For example, I worked for many years at MCI, and we accumulated a lot of information about people's calling practices because we had to bill them. So we had the date and the time and the length of the call and who you called and from what number, and we used that for billing. But it's easy to see how that could be treated as very personal information as well. So the company treated it as personal and didn't release it except under certain legal conditions. The problem is if that information happened to be in a disk drive or on a thumb drive and that got lost because somebody just wasn't paying attention, that's another incursion into personal privacy. So I see a lot of reasons why privacy gets invaded, not by intent, but simply because of poor practices. And of course, there are a lot of invasive devices now. In fact, every one of us with a mobile, in a funny sense, is a source of potential personal invasion because we can take videos, we can take audio recordings, we can take pictures, we can publish them on the net, and we do so with considerable abandon. And now people go through, for example, Flickr, and they tag photographs. So all of a sudden, there's a little photograph that you didn't know was being taken that identifies you being in a place where you weren't supposed to be, or you said you were somewhere else, and somebody says that's interesting because there's a picture of you on Flickr that says you were over here, and you can't claim that it was Photoshop that did it. And so there's a whole lot of problems here with personal privacy because of the fact that we've all become reporters in some sense, and we've created an environment where we can share that information with anyone that we want to. Those of you who go through toll roads with your little RFID chips, that's wonderful convenience. You don't have to stop and put money into the collecting bin. But if somebody else puts RFID detectors where you don't expect them, then you could be tracked. But even the simple case, the one where you are going through the toll roads and everything else, they keep a record of every toll booth you went through. And at the end of the month, they'll send you a list of where you went and how much it costs, and here's how much we decremented your account for. But you can imagine some people thinking, well, that's kind of personal information because it says where I was at a certain time. And maybe you don't want that to be made public. So you care that the companies that accumulate that information protect it. There are some new technologies that are coming along in the net, and I just wanted to draw your attention to them because the important point here is that the net is not static. The network, even though the design was done many, many years ago, I mean to be accurate, 37 years ago, there are new ideas that are sort of emerging out of the technology community. There's things called flow routers that Nick McCune and his team are doing at Stanford, which are a very different view of how you manage packet flows than just source and destination addresses, giving a substantially more flexible amount of control over the way in which packets are routed through the network. And then there are these huge capabilities to do lots of correlation on data. I mean, we clearly do that at Google, as do others. Jeff Jonas, who, if he hasn't spoken at World Wide Web, should be invited. He's just an amazing guy. He builds very, very large databases, sometimes dealing with the intelligence community, and has this idea that every time you get a new piece of information, you should present it to the database as if it's a query in order to find out what things in the database that new piece of information might be associated with. It sounds funny on the surface, but it's exactly right, because here you find out whether a new piece of information is related to anything else and does it conflict with anything else. There's the tweet stream. There's all kinds of sensors that we have available. There's a huge amount of information is becoming more and more accessible to tools that allow for correlation and the like. Cloud collaboration is another area that's new in many respects. We don't have collaborating clouds. What we have is a collection of independent clouds, the ones that are made by Google or IBM or Microsoft or Amazon. I would compare today's cloud world with the world of networking in 1973, when the internet ideas were first beginning to unfold. There were networks of computers in that time frame, and they worked very well. IBM had SNA, Digital had DECnet, HP had DS. There was ARPANET was running. So networks were clearly there. The problem is that every network thought it was the only network in the world. You didn't have any way of even saying, send this to some other network. There was no vocabulary for that, which is what the Internet Protocol contributed to. So there are lots of attractive things today about clouds. You can replicate them, which is what we do at Google. And you replicate the data in order to make things very resilient. You can do dynamic capacity sharing. If you have a task that requires a lot of computing, you can allocate it temporarily and then reallocate it when that task is done. The idea of sharing data and collaborating with other people is very powerful in the cloud paradigm. If I have a Google Doc, for example, I can work on that doc online, and if other people want to work with me, they can see the changes that I'm making to it in real time. We can have our headsets on and have a conversation. So the idea that where's the latest copy, it's always the one that's in the cloud, is very convenient, as opposed to who has the most recent copy or who's in charge of editing the document that might be sitting on a laptop. So the thing has now that poses itself is that if we have information in a cloud, how do we get it out? And one reason for wanting to get it out is that you don't want to be trapped in any one particular cloud. Google calls this data liberation, and we're very concerned that you be able to get your information out of the cloud if you want to move it someplace else or replicate it someplace else. So there are a bunch of little problems, and there's a list here which I won't go through entirely, but how do I refer to another cloud? How do I cause it to disgorge data? How do I make the cloud send data to another cloud? If I have information in cloud A that's access controlled, and I want to move the data to cloud B, I also need to move the metadata that does the access control, and I need for cloud B to interpret the metadata the same way cloud A did so that the access control continues unabated. There are all kinds of things that we might want these cloud interactions to accomplish for us. The clouds today are very different in their implementation. So I don't for a moment believe that we could simply stand up and say we should all build all of our clouds exactly this way. But for the internet historians in the group, some of you will remember a protocol called Telnet. And one of the properties of Telnet was it defined a network virtual terminal. This was something that didn't exist, but every computer in the ARPANET agreed that if there were terminal interactions coming to it from the ARPANET, then it would accept terminal interactions expressed in this NVT, Telnet form. So if every computer was able to at least interpret that, and if it exhibited this network virtual terminal when its users were trying to get out to another time-shared machine elsewhere on the net, they all agreed that this network virtual terminal would be the lingua franca. So you can imagine a network virtual cloud. This is the idea that you exhibit yourself to other clouds in a certain standardized way. It may not reflect everything you're capable of doing, but at least it becomes a basis for allowing data exchange and possibly collaborative computation between clouds. Then you try to grow from that basic understanding. So network virtual cloud may turn out to be a kind of way of moving forward to get clouds to interact with each other. We are fortunate that bandwidth seemed to be growing faster and faster, and that storage is getting bigger and bigger. If you remember the little movie Short Circuit about the little robot that was alive and it got into a bookstore and its reaction was input, and it read every book in the store in about 20 milliseconds. So we have huge amounts of information that we can either move or store. Of course, there's a little problem. We can store it, but sometimes the data rate isn't very good, and it takes a long time to get stuff out. You know, if you have a 10 terabyte disk drive, you may not be able to search it as quickly as you would like. So, we're introducing solid state storage, but I think we're going to have to see a significant transformation in the way we process stored information by somehow integrating processing and storage into a common package. If you look at a data center today, it's rack upon rack of PC-like motherboards with high-density storage, rotating storage, or sometimes solid-state storage with each processor. And if you were to kind of step back for a minute and imagine projecting that architecture down onto a chipset or onto a motherboard, you would see the mixing together of the processing and the data in the same structure. And I think that's ultimately where we're going to end up having to go in order to make things run more quickly. I can't help but take a moment to observe that there are things on the internet that Bob Kahn and I am sure never anticipated, like refrigerators and picture frames, phones that look like phones but they're voice over IP computers. The guy I like the most is the one with the internet-enabled surfboard. He's in the Netherlands. I've never met him, but I have this image in my head. He's sitting on the water, waiting for the next wave to come, thinking, if I had a laptop on my surfboard, I could be surfing the internet while I'm waiting, for the next wave. So he built this internet-enabled surfboard, and he put a Wi-Fi service back on the Rescue Shack, and he sells this as a product. Now, I mentioned to you that sensor nets are coming to the internet. I have a small example. This is an IPv6 radio-based commercial sensor network that I run in the house. It comes from a company called Archrock. And the system is sampling the temperature, humidity, and the light levels in the house every 5 minutes and recording it on a server that's sitting in a rack in my basement. Now, you might think that's just a geek thing to do, but in fact, I had a practical purpose. I wanted a year's worth of information about the heating, ventilation, and air conditioning system in order to understand how well or poorly it was functioning for each room in the house. So now I have several years of data available, and we can adjust the system in order to do a more efficient job of distributing heating and cooling. One of the rooms in the house is the wine cellar. This is a very important room to me. It's got a couple thousand bottles of wine in it, and it's important to keep it below 60 degrees Fahrenheit and above 50% humidity. So it's alarmed. If the temperature goes above 60 degrees, I get an SMS on my mobile. This actually happened. I was visiting Argonne National Laboratory last year, and just as I'm walking into the building, the mobile goes off. It's the wine cellar calling. It says your temperature has just breached the 60-degree Fahrenheit barrier. And unfortunately, my wife was away for 2 weeks on a holiday, and I kept getting this every 5 minutes. I get a message saying your wine is warming up. I couldn't do anything about it. I got home, it was 70 degrees in the wine cellar. So I called the Archrock guys, and I said, do you have an actuator that I can run remotely? And they said, yes, that's a weekend project to go put all that together. Then I thought, this is cool because I can see the light levels. And so if somebody goes into the wine cellar when I'm not at home, I can tell that they've gone in there because the light went on. But I don't know what they did. So somebody suggested, why don't you put an RFID chip on every bottle? And then you can do an instantaneous inventory of the wine to see if anything has left the wine cellar without your permission. But one of my engineer friends debugged the design and said, you could go into the wine cellar and drink the wine and leave the bottle. So we're going to have to put a sensor in the cork. If you're going to go to all that trouble, you might as well put a chemical sensor in to detect the state of the esters that make the wine taste the way it does, and then you interrogate the cork before you open the bottle. And if this is one of those bottles that got to 97 degrees when the cooling went off, you give that to somebody who doesn't know the difference. Okay, so I'm really quite certain that we're going to see more and more sensor data coming to us over time. And I'm pretty sure that a lot of this will be built into the buildings, it will be built into our mobiles, and built into the cars. And it will help us do a better job of understanding our environment and somehow living more effectively with it. The smart grid is another manifestation of that. And there's just a huge number of things that you can foresee coming. Now, not only that will increase dramatically the number of things that are in the network, but also the amount of information that we have to process. And of course, for many of you, that will be a big opportunity. Now, I know that I have a finite amount of time here, so I'm only going to show you a few slides and ask you to consider the consequences without going into any detail. There are still an enormous number of things that the net does not do that it should do that would make a difference to people building web-based applications. I mentioned mobility already. Multi-homing, multi-path routing, the ability to route traffic simultaneously in several different paths to get more capacity out of the net. Broadcast, let me dwell on that for just a second. We take broadcast channels and turn them into point-to-point links. That's what we've done with Wi-Fi. And when you think about it, there are opportunities to distribute information very efficiently, taking advantage of broadcast. So an example, one image I have in my head is a synchronous satellite that is capable of reaching 100 million receivers, literally raining internet packets down on all those receivers. If you have information that lots of people need to get, for example, a software update for a popular operating system or application, this could be an extremely efficient way of distributing things. If it's video entertainment, for example, again, distributing the data that way, or other kinds of data anymore. And so, you know, the crappy software that you write doesn't get better because the clock speed went up. Sorry, I don't mean to offend anybody. I'm a software programmer too, and I know how crappy my software is. But I used to rely on the fact that Moore's Law made my software work better without any further work from me by increasing the clock speed, but that doesn't happen anymore because when you increase the clock speed, it takes more power, dissipates more heat, the chip melts. Somehow that doesn't work well. So we end up having multi-core chips which don't have an increasing clock speed. The consequence of that is that your algorithms to take advantage of the compute power have to be operable in parallel. We're lucky at Google, a lot of our applications easily can be parallelized, but for those that can't, you have to really think hard about how to redo the algorithms to make them work well in a multi-core environment. Governance is a huge subject. I'm not even going to touch that except to say that the internet, even at 26% penetration around the world, has become a major topic of governance questions. What does it mean to operate in this cyberspace environment? What does law enforcement do when someone commits fraud in one country and harms somebody in another country? We don't have any multilateral agreements yet. We have small, bilateral agreements here and there, but we don't have a common law of the net in the same sense that we have a law of the sea, and I foresee the need for that in order to operate in cyberspace in any kind of a rational way. I already talked about mobiles. Gosh, performance, all kinds of issues here. So I think the basic point I want to make here is that there is a lot that can still be done to today's internet to make it a lot better. So while you're operating up here in web space, there is a whole lot of potential evolution and even turmoil in the lower levels of the system that support you, and lots of opportunities for improvement. Let me just finish up by mentioning some things that I'm very worried about. One of them, clearly intellectual property, and a lot of the things that you deal with probably touch on that. The problem with the World Wide Web is that it's a giant copying engine. The first thing a browser does is go out and download a file, copy a file from the home site. And for anyone whose intellectual property protection model is to prevent people from making copies, this is pretty terrifying. Now, the solution to the problem is not, in my opinion, to exercise huge amounts of DRM and everything else. I think the real point should be to step back, both from the technical and the legal point of view, and ask the question, what ways are possible to compensate people for the creation of intellectual property without necessarily relying solely on the control of copying as a way of assuring compensation? So I don't claim to have an answer to this, but I do think we need to ask this question in a more fundamental way rather than trying to replicate the real world's method for the physical world's method for dealing with intellectual property protection. The semantic web we've already talked about. One thing I'm quite concerned about is that as time goes on and as the applications that you and others make are in use, we create very complex objects. as a consequence of using these applications. A spreadsheet or a Word document or something like that are all examples of complex objects whose information is not interpretable without the application software to go with it. So the question is, what happens if that application software is no longer available? Or what happens if it has migrated on in its evolution and isn't backward compatible with the complex objects that we've accumulated over time? I think of those piles of complex objects as rotten bits if we don't know how to interpret them. The simple scenario that I keep reminding myself of, it's the year 3000. You've just done a Google search and you've turned up a 1997 PowerPoint file. And let's assume you're running Windows 3000 just, just to make it concrete. The question is, does Windows 3000 know how to interpret a 1,000-year-old PowerPoint file? And there's a high probability that it won't know how to do that, even if we're using open source. Open source may not necessarily be preserved and survive over time. So we really need to build in, I think, into our institutions and our practices the ability to hang on to operating systems and applications over a long period of time. There's intellectual property associated with these things, at least in some cases. So we're going to have to invent schemes that provide incentive for people to keep that older software around so that it can be used. Maybe it's in the clouds and maybe we emulate some of these things. Now, the model that I've had in my head up until last night when I was talking with Thomas Rosler was sort of a single computer with an application running on it and a thing that it interpreted. And I was sort of comfortable with the idea of, okay, we'll park the operating system in the cloud and we'll emulate the hardware and we'll put the application there and we'll make an arrangement for whoever owns it to allow us to do that. But then in the course of the conversation, I realized that some of the stuff that you're doing creates a distributed computation environment. And it's that distributed computation environment that is doing the application. And the data is distributed across, the gigantic, like we do at Google with the map and reduce structures and Bigtable and so on. And so suddenly it isn't just a question of preserving this one instance of an application running on a particular operating system. It's figuring out how to preserve and replicate a distributed computing environment over time. Eek! That's hard. And that says, I don't even know how to think about that yet. So the problem is that if we don't find solutions to these things, we will leave a pile of rotten bits for our descendants. And in the 22nd century, they'll look back on the 21st century and they'll wonder, what was life like? Because they won't have any way of looking at all of our, by that time, rotten bits, unless we figure out how to preserve applications. So let me stop there and let me thank you for allowing me to start this conference out this morning. And I look forward to some Q&A if we have time for it. And I'm happy to engage. Thank you very much.